I'll be demonstrating the personal NoSQL project. As we all know, the latest storage systems in distributed computing either focus on consistency and partition tolerance or on availability and partition tolerance of the cap triangle. So, it is important for us to practically understand the partition tolerance in both the CP and AP systems. Here, for testing the partition tolerance, I'll be using MongoDB for the CP system and Riak for the AP system. Let's now get started off with the experiments on CP system. I began by creating a MongoDB cluster with 5 nodes. The topology of the cluster I created is as shown in this figure. It is a master-slave replication model where the primary node acts as the master and the other secondary nodes act as the slaves. All the updates are made to the master, which then propagate to the slaves. The data can be read either from the master or from the slaves. I'll now be showing you the AWS console. All the instances here in the running mode form the nodes of my cluster. I have created a security group named MongoDB cluster. I have associated this security group with each of my nodes. The port 27017 is the default MongoDB port and hence is open. I'll want to connect to all of my nodes from my system by SSH, so I have the port 22 open. All the steps that I've performed in creating the MongoDB cluster are mentioned in this project journal. I have configured the replica set on each of my nodes. I've initiated the replica set from my primary node so that the primary node acts as my master. I've also created an admin user to securely access the data. Let's now test the cluster in normal mode. Here, the green terminal is the connection to the primary instance. The other terminal windows show the secondary nodes of my cluster. I have logged into the database through each of my instances as an admin. Let's now try to insert a document into the database through the primary instance. The document has got inserted. Now let's try to access the document from all the nodes of a cluster. Yeah, we're able to retrieve the document that was inserted. Even before trying to make a read operation from the secondary, we'll have to set the secondary nodes as the slaves of a cluster. So I've done that using the rs.slaveok command. Let's now try to read from the secondary nodes. We're able to retrieve the document that we have inserted from all the nodes of the cluster. So the data that was inserted is consistent across all the nodes of the cluster. Let's now try to update the document through the secondary node of a cluster. It says this operation is not possible because the secondary node is not the master. Under normal mode, our cluster is behaving in a master-slave fashion as expected. Let's now try to create a network partition and test the behavior of the cluster. I've chosen to use IP tables, a command line firewall utility, to isolate one of the nodes from the rest of the members of the cluster. I'll be testing the partition tolerance by making one of the secondary nodes unavailable. I'll be isolating the secondary 2 node. As we can see, I have the IP tables rules ready with appropriate IP addresses corresponding to primary and the other nodes. These IP tables rules will block the traffic to the secondary 2 node from the other nodes. We'll now be adding these IP table rules to the secondary 2 node. Let's now check if the IP table rules are inserted as expected. We can see that the IP table rules are now available at secondary 2 node. Now let's check the status of the replica set through our primary instance. We can see that the secondary 2 node is not reachable or healthy. Now let's try to add a new document into the database through the primary instance. Now let's try to query for this. Let's do this through all the nodes of the cluster. We are able to read the documents that were inserted before and after the partition was introduced. Let's now try to query for the document through the node that is unavailable for us. For this, we'll have to log in to Mongo as an admin. Let's now try to query the database. Okay, it says it's not a slave. So let's make this node the slave in the cluster. Now let's try to query it. So we can see that the secondary 2 node has stale data. Hence, we can understand that during partition, we have consistent data on all those nodes which are available on the replica set. We'll now recover the secondary 2 node from partition by removing the IP table roles. We'll try to check the already existing IP table roles on secondary 2 using this command. So we'll remove each of these rules one by one. We should be using this command to remove the rules. We'll execute this command 4 times so that all the rules get removed. We'll once again check if all the rules are removed. Yeah, there are no other rules left on the secondary 2 node. We'll now check the status of the replica set. We'll do this through the primary instance. We can see that the secondary 2 node has again become available. Now let's see if the secondary 2 node has the document that was inserted during partition. For this, we'll have to log into the Mongo database as admin and query the database. Let's now set the secondary node as slave in the cluster. Okay, it says let's now search command. Yeah, now let's try to query. The secondary 2 node reads both the documents that were inserted before and after the partition. So we can understand that soon after the secondary node became available, it has attained consistent data. Now the primary node is made unavailable by introducing the IP table rules. Let's now check the status of the replica set. We are doing this from the secondary instance. We see that the primary instance is no longer available. It is no longer acting as the master. We understand that whenever the primary instance becomes unavailable, there is an election that happens among the secondary instances, and one of the secondary instances is chosen to act as the new master. Let's now try to recover the primary node from partition. Let's first list the rules that we have included. We'll remove all of these rules one by one. We'll again try to check the status of the replica set. The primary instance has now become available, but it continues to act as a slave. It's no longer the master. Thus, from the whole of the demonstration, we understand that during partition, MongoDB is a consistent system. Now, let's move on to the experiments with AP system. Riak is a key value data store that offers high availability, fault tolerance, and scalability. To ensure these benefits, the Riak cluster shall have a minimum of 5 nodes. So, I have created a Riak cluster with 5 nodes, the topology of which is as shown in this figure. First, I created two VPCs in two different regions of the AWS. The first VPC in the region North Virginia has the Riak nodes 1, 2 and 3. The other VPC in the region Northern California has the Riak nodes 4 and 5. The two VPCs are connected by VPC peering. This is done to ensure that the nodes in the two regions of AWS are able to connect to form the cluster. I'll now be showing you the AWS console. The nodes Riak 1, Riak 2 and Riak 3 are running in the North Virginia region. The Riak nodes 4 and 5 are running in the Northern California region. I'll show you the peering connection. This is the peering connection that connects the VPC in North Virginia to the VPC in Northern California. I'll show you the route table that enables the VPC peering. This is the route table corresponding to the subnet that contains the nodes Riak 1, 2 and 3. And this is the route that we included, which is corresponding to the peering connection. This is the peering connection ID. Similar peering connection and route tables are also available in the Northern California region. All the steps that I have performed in creating this cluster are listed in this project journal. I have launched each of the cluster using the AWS Marketplace AMI Riak KV 2.2. I have created the security group that I have associated with each of the nodes. This security group has all the ports corresponding to Riak interface open. I have made the Riak 1 node as the admin node. All the other nodes connect or join to the Riak 1 node to form the cluster. The cluster plan is then verified and is committed. The cluster, which is running on AWS, will look like this. Now we'll test the cluster in normal mode. I'll be using Postman to test the cluster. I have created a GET request corresponding to the 5 nodes. I've also created POST request corresponding to 1 node in each region. Actually, any of the 5 nodes can be used for both the read and write operation. Let's now try to insert a key value pair into the database through the Riak node 1. If we look at the URL, we are making use of the public IP of the node and also the port 8098, which is the HTTP interface of the Riak. So let's now post the key 7. It's got inserted. Now let's try to retrieve the inserted key 7. Let's try to retrieve it from all the nodes. So the inserted value is consistent across all the nodes. I'll now create the network partition and test the behavior of the Riak cluster. I'll be disturbing the VPC peering connection to create the partition. I'll show you how I do that. I'll be removing the route corresponding to the VPC peering connection from the North Virginia region. Let me edit the routes, delete the VPC peering route, save it. So the network partition is created. Let's now test this. Let's now insert values into the database through different regions, that is through Riak 1 and Riak 5. First, let us insert the key 8 with this value into the database. It's got inserted. Let's now try to retrieve it from the region 1. We are able to get the value. Let's try to retrieve the key 8 from the region 2, that is the Northern California. So it says not found. Let's now try to retrieve it from node 4. Again it says not found. Let's now try to insert the key 8 from the region Northern California, that is from node 5. Let's give a different value. It's got inserted. Let's now try to retrieve it from the different regions. So the region 1 has the old value itself. Let's see the region 2. So the region 2 retrieves the value that was inserted from the Riak node 5. Hence, we can see that during partition, the data is not consistent across the nodes, but all the nodes are available for the users for both the read and write operations. The routing rule is included back into the routing table to establish the peering connection again. The rule used by the Riak DB is to retain the last written data for bringing back the consistency in the system. In my example, the last write was done by the Riak node 5. It inserted the key 8 with the value CA MySQL. Now that we have recovered from partition, we can expect this value to be propagated to all the nodes. Let's test from the nodes in both the regions. The Riak one, initially it was retrieving the value CP MongoDB for the key 8. Now let's check what the value it is retrieving. So now the value that it is retrieving is CA MySQL. Let's check from the other nodes too. All the nodes have the same value for the key 8. The data is consistent across all the nodes. This demo hence shows that the Riak is a highly available system during partition and is able to achieve eventual consistency upon the partition recovery.